Hello everyone, and thank you for making the time to look at this video today. I'm a student in Higher College of Technology, studying mechanical engineering and taking one of the most important courses in mechanical engineering division, which is Applied Dynamics, and this course is given by Dr. Amjad. In this video, I have been given the task to solve a kinematics problem, more specifically problem 12.19. Kinematics is the study of, uh, of motion without referring to the forces that causes that motion. So I'll begin by stating the problem, which states that a particle, as you know, a particle is an object without dimensions, travels to the right in a straight line, which has a velocity equal to 5 over 4 plus s. Where s is in meters, we should determine the position of this particle when t is equal to 6 seconds. And it is given in the problem that when the particle was at 0 seconds, it has a position of 5 meters. So to sum up the givens of the question, it is given that s is equal to 5 meters when t is equal to 0, and v is equal to 5 over 4 plus s. And we are required to get the position. So I'll begin the solution by referring to a very important equation that we studied in the beginning of this course, which states that the velocity is equal to this ds over dt. And as you know, in the one of the givens of the question is v is equal to 5 over 4 plus s. So we can equate these two equations to result in ds over dt equal to 5 over 4 plus s. And to further simplify this equation, we can cross multiply these two to result in 4 plus s ds equals to 5 dt. And as you know, that the derivative of s is equal to velocity, and the derivative of velocity is equal to acceleration. And to track back from velocity to position, we should use integrals, and we should here integrate both sides of the equation. And given in the question that is s is equal to 5 when t is equal to 0, so we start our integration from 5 to 0, and here from to 5 to s, and here from 0 to t. So we resulted in this equation. So using the previous knowledge we obtained from the different calculus that we studied, we can integrate this equation to result in 4s plus s squared over 2 plus minus 32.5 equal to 5t. So we can simplify this equation to get 4s plus 0.5 s squared minus 32.5 equal 5t. So we are required to get s when t is equal to 6 seconds. So we should substitute 6 into this equation to get 4s plus 0.5 s squared minus 32.5 equal to 5 times 6. And we can simplify this question to get this quadratic equation, which we can use our calculators and go to mod 5 3 to solve this quadratic equation. And we result in two answers, the first one being s equal to 7.87 meters, the other one being s equal to minus 15.87. So we end up with two values, one is positive and one is negative. Of course, we go with the positive one because in the question it stated that it goes to the right. So finally we get the answer of the position being as 7.87 meters when t is equal to 6 seconds. The problem gave us a position of a particle at 0 seconds. And integrations was used to get the position of the particle from the given velocity equation. And in conclusion, because of the velocity of the problem, because the velocity of the problem was not constant, the position was determined using integrations of the velocity equation. So I'd like to thank you all for listening, and goodbye.